Well, hello Maths Applied students. You guys are too noisy today, so I thought I'd get rid of you all and have a go at this example with you guys out of the room, so it would be nice and quiet and you could hear exactly what's going on. So we're going to do a break-even example. So typically what we're dealing with here are business type situations, a business trying to decide, okay, how much do we need to make to break even in this situation, and businesses come across costs. So a business might have fixed costs of, say, the rent for a factory, wages for employees, that sort of thing. So rent, wages, just general fixed costs of doing business. These don't change from time to time, or these don't change depending on how many items they make. Now, variable cost is to do with the number of items, so this changes with the number of items produced. So typically variable costs depend on the materials, because the more items you make, the more material you require. So the greater your variable cost. So we're looking at materials there. Okay, now revenue and profit are often confused with one another. Revenue is actually the money gained from selling goods. Whereas profit is the difference between revenue and costs. So profit's equal to revenue minus cost. I mean, you might sort of think, oh yeah, well, let's say that you were going to sell something, lemonade at a stand. You go out and you sell $50 worth of lemonade. So you've got $50 in your pocket. Now, can you justifiably say that you have profited by $50? Well, not really, because you have to pay some money to begin with for the lemons and the sugar and all that sort of stuff. So you've got to subtract your costs. You need to subtract your costs from your revenue. That $50 you've made for the day, that's your revenue. That's the money you've gained. Once you subtract your initial costs, which come from these fixed costs and the variable costs, then you've got your profit. So revenue and profit are different from one another, although there is a relationship there within this equation here. Okay, so we've got a manufacturer here who's making a certain item. There's not a lot of description here of what that item is, but we do know that we've got fixed costs of $600 daily. Rent and wages for employees, they amount to $600. Now, the variable costs are $12 per item. So variable costs, $12 per item. So the more that you make, each extra item you make, it's going to cost you an extra $12 to make it. But that's okay, because you can actually sell the items for $26. So each of these different bits of information relates to a different part of the cost equation and revenue equation. So let's see, we've got fixed costs of $600 and variable cost of $12 per item. So the cost equation, the C for cost equals fixed costs of $600 plus, now each item is $12, so 12 multiplied by X, the number of items. So we have C is the cost in dollars, and X, number of items. So the cost equation is $600 plus 12x, where x is the number of items being produced. revenue equation. Okay, so how much do we sell these for? First off, R for revenue equals, if we sell one of these, we've got $26 because 26 times 1. If we sell 10 of these, well, it's 26 times 10, so the revenue will be $260. So it's a simple multiplication, 26x. Now we've already defined x up here. We know what x is, that's the number of items. We haven't said what R is. R is the revenue. And that's also measured in dollars, just like the cost. Okay, so let's graph the two equations. Okay, so we've got the cost equation first. So you can have a go at plugging these values in. Okay, so cost. No items. Well, the initial cost, that fixed cost is $600. Okay, so the next one we've got 600 plus 12 by 50 because 50 items are being made. So 600 plus 12 by 50, $1,200. Okay, then the next one, X is 100. So you want to see a lazy little trick on the class pad, just change that number. Let's give you the other one, so $1,800. Okay, ripper. Alright, so revenue now. Well, the number of items is 0. Well, you're not going to be selling any items, so it must be 26 times 0 gives 0. No money being made. Okay, so let's go to the class pad now for 50 items. So that's simply 26 by 50. And while we're here, we'll do the other one, 26 by 100. So if we sell 100 items, that's how much revenue we're going to get. So we've got 1,300 and 2,600. Very nice. So let's graph these. The trick is always, so okay, what's the biggest number for the dependent variable on the x-axis? Sorry, the independent variable on the x-axis. Okay, so we're going to go up to 100. So 10, 20, 30, 40, 50 looks good. $60, $70, $80, $90, $100. Mine's a little hard to squeeze in here, but I'll put it down here. We've got number of items, X, along that axis. And up along here, well, we're going to go up to 2,600. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this looks like we're going to go up in 200s. 2, 4, 6, 8, 1,000. 2, 4, 6, 8, 2,000. 2, 4, 6, 8, 3,000. Whoopsie, so I made a little boo-boo there. Gotta fix that one up. This didn't seem right. 2, 4, 6, 8, that's better. 2,000 and 3,000. And this is cost and revenue measured in dollars. So hopefully you were watching when I deliberately made that mistake with the scale, just to test you out there. Okay, so let's graph the cost. So 0, 6, 50, 1,200 and 100 and 1,800. Move him down a little bit. A bad one with this, but we're getting there in the end. Okay, this should join up in a nice straight line because it is a linear relationship. Okay, it's very good. We'll label our endpoints here as well, of course. So we've got 0 and 600, got 100. Bear with me here. 100. And 1800. Just going red there so it'll stand out against the blue. Okay, then the revenue. So we've got 00 down here. Along the way, 50 and 1300. I mean, you don't really need to get these ones that are in the middle. Oops, get out of the way. No, we don't want that. Sorry about that. Okay, so yeah, these ones that are along the middle, you don't really need them. It's a straight line. It's going to go all the way along. But we'll put them in because we've calculated them just to make sure. 2600. So that looks good too. So this was 100 and 2600. Okay, so far so good. So just have a quick look at that. Get that one out of the way. There's your graph. You see that there's a distinct point where the lines cross. What does that mean? Here it is here. There's a point there. What does that point tell us? Find the break-even point graphically and algebraically. Well, of course, that little black dot is the break-even point. There he is, right there, that little black dot. Am I moving the cursor enough for you to see that? That's the break-even point. So we're asked to find that algebraically as well as graphically. Graphically first. So let's have a look. Going up. And then across. Have I got that straight? That looks okay. So to me, that looks like, well, we've got 20, 10, 20, 30, 43. So about 43. And that's 2, 4, 6, 8, 1,000. That'd be 1,200. So just over 1,100. I'll just say 1,100. Once again, you always remember that graphs are a little different because, well, everyone's going to get a slightly different answer. Graphs are a bit like a fingerprint because we do it by eye. Our own little inaccuracies come in, and that makes it difficult to get to be exact with a graph. But of course, the algebraic answer will give us the exact answer. So graphically, we've got 42 and 1,100. That was our graphical answer by the graph. So 42 and 1,100 graphically. So algebraically, okay. So that means we've got to now do this by equating the right-hand sides of the two equations. Our equations over here, the cost and revenue. Think about it. When your costs are equal to your revenue, you've broken even. So we want revenue equals cost. That means break even. Okay, so the revenue equation was 26x equals the cost equation was 600 plus 12x. Okay, so once you've written that out, you've satisfied the requirements there for the amount of algebra, amazingly. Now, it's not maths methods, it's maths applied. So you've written that down. So you can now go ahead and solve that on the calculator. don't really need that bracket there. So we break even at 42.86 items, which is close to what the graph said. We said 42. And of course, you can't have 0.86 of an item, but it's a break-even point. So we don't round off in this case, even though I know it doesn't make sense to have 0.86 of an item. Because we're asked for the point, we don't round off, and we'll see how these questions will be distinguished later on. So just go with that point for now. Okay, now we need to find the point. As I said, we need the point, so we can't just go and give x equals, or number of items, 42.86 rather. You've got to find the y coordinate point as well, the y value, which would be revenue or cost. There are two ways to do that. You can substitute this number back in to the revenue equation, so just multiply it by 26. Or, slightly more laborious, but you can just put it into the cost equation too. That's allowed. You get exactly the same answer, of course. Maybe it's a good thing to do both just to make sure that you've got it correct, because you should have the same answer pop out both times. So 42.86 and 1114.29. 42.86 and 1142.89. Just recheck that quickly. And got you guys to check it. It's 29. So it's 0.29. So that's our break-even point, algebraically. Not bad compared to the graph. Not bad. Not bad at all. Not too far off. Okay, find an equation for the profit involved in production. So we said before, profit equals revenue minus cost. Profit, P for profit, equals R for revenue minus C for cost. So we need to put our R or our revenue and cost equations into this. So revenue is 26x minus cost is 600 plus 12x. Now here's a really common mistake. I want you listening to this. Listen very carefully. Students always just write this out and say, oh yep, there we go, simplify this, yeah, 26x, 12x, bring them together. You need to remember that has come in as a single lump, that cost. So you need brackets around it. Very common to forget the brackets. Very common to forget brackets. Okay, don't forget the brackets. So 26 minus 12x leaves us with 14x. That negative goes onto the 600. And there's our profit equation. There's the profit measured in dollars. So there he is. So this last one's quite achievable now. X equals 80 items. It's a straight substitution. We've got an equation for profit, so you can find what the profit should be or will be for any number of items that are produced. $520. Okay, so there it is. We got anything over the page? No, that's it for now. There's a more complex example coming up next time. So right now I want you guys to concentrate on some of these types of questions. Now I gave you the sheet which says try these break-even questions. So let's write that. Try these BE questions? Well, let's have a go at number 1. And let's try number 3. What do you reckon? Number 5. Let's stay with the odd ones, eh? 1, 3 and 5. Of course, if you're diligent, you'll have a go at 2, 4 and 6. But I know that you guys are pressed for time, as we all are. There's only so much we can do, so 1, 3 and 5 is fine. Okay, I hope you enjoyed this internet presentation style. I want you guys ready when we get back together on Friday to be able to tackle the more complex break-even situations. If you're feeling that you're not up to speed with these, of course you must come and see me outside of class and we can sit down and go over these again. Thanks for watching, guys. See you Friday.